Hey everyone, welcome to my talk. This is Test2 for test authors. I'm going to be going over a lot of Test2 in a very short time. I will take questions as I'm going. Just raise your hand. That's fine with me. Going to start off with some very basic things, but if you sit through that, we'll eventually get to the more complex and interesting stuff as well. But this is for all levels of testers. But just out of curiosity, raise your hand if you've written tests in Perl at all. Okay. How many of you use Test More or have used Test More? How many of you have already tried out the Test2 stuff? Good amount of you. Okay. Well, let's go ahead and proceed. By the way, if there was working internet, you'd be able to follow along here. But all of this is always available online. So Test2. Test2 is the new framework to replace TestBuilder. And that is because TestBuilder has really outlived its design. Up until I started the Test2 stuff, it hadn't had any major overhauls since it had been written, just minor feature additions. And lots of people wrote really rich testing tools that really had to contort themselves to work with TestBuilder, because it just didn't provide what it needed. There were a lot of things out there that would re-bless the TestBuilder singleton or replace it completely. Lots of monkey patching, just because the capabilities were too limited. Now, I say this as a replacement for TestBuilder, but TestBuilder itself is not going away. In fact, TestBuilder has been refactored to use Test2 under the hood. So any tools that use TestBuilder are fundamentally compatible with Test2. Existing tests are not going to break, for the most part, if you just download the newest Simple distribution, which includes Test2. There's a few exceptions to that. There are a few things that broke, but they don't affect most people. So now I'm going to show you some benchmarks here. Test2 takes a bit longer to load than the legacy tools. Like if you use Test More before Test2 was a thing, you'll see that it takes 3 times as long to start your test. That is simply loading Test More or whatever tools you're using, load TestBuilder. That slowdown is unfortunate, but I've not been able to optimize it to the point where it's back on par with TestBuilder. This will affect you if you have a lot of tests that start and finish really quickly. Like if your total test run is only measured, this many decimal places, you will notice a slowdown then. But most people have tests that take significantly longer, where the overhead of starting each test file isn't actually going to matter. So that's not where the focus on optimization has been. However, when we then look at performance for running tests, Test2 is significantly faster than TestBuilder ever was. And even if you're now using TestBuilder that's based on Test2, it is notably faster. This is only going to affect you if your test runs for a long time and makes a lot of assertions, because realistically, no one runs 100,000 assertions in a single test, not very often anyway. So Test2 is not likely to slow down your test suite at all, but the performance gain it gives you is not likely to be noticed, because most of the time in tests these days is taken up by the logic you're actually testing, not by the framework. But one of the goals was to make sure the framework didn't slow you down. So TestBuilder, before I ever touched it, to run 100,000 OKs on this machine, 3.8 seconds. Now with Test2, it's 3.3 seconds, marginal gain. If you just use Test2 and don't use any tools that load the legacy TestBuilder, it is significantly faster at 2.3 seconds. Then I also got benchmarks for threads. TestBuilder legacy did support threading, but you had to enable it before you actually ran any tests. Simply having that code active slowed it down. This benchmark is still 100,000 OKs with no threads actually started. It's just significantly slower because of the threading overhead. TestBuilder on top of Test2 with IPC support, which is called IPC because it now supports forking and threads. Not faster than legacy, but faster than legacy with threads. And then Test2 without TestBuilder and the IPC is still faster than regular TestBuilder legacy was. So those are some pretty big improvements there. In fact, if you do have threaded or forking tests, you will see a lot of gain from the performance enhancements here. Any questions about this before I move on to the tutorial? Think. test-more.github.io/test2-manual. Yes. Okay. Since most of you have testing experience, I'm going to really go through this tutorial quite quickly. It's just an example of starting a brand new test with Test2. First, the boilerplate. Use Test2 : v0. This is different from my recommendation last year of using TestBundle extended. This is actually the same thing, but after talking with a few other people, we want a path forward. So you use Test2 : v0 to get all the benefits of Test2 suite. In the future, if we need to make any breaking changes, API changes, whatever else, we will release Test2 : v1. Nothing that uses v0 will have to change, update, or break, but moving forward, you can use v1 to get all the new benefits, the new enhancements, and bug fixes. This is the same model Perl 5i was going to use before it flopped. So planning, most of you know how to do testing, so you know you need a plan to make sure that all your tests actually run to protect against an early successful exit. You can do that by counting how many tests there's going to be and setting the plan directly. You can put done testing at the end of the test, which is what I recommend. And in some cases, you want to test a skip, so you could use the skip all to just abort the rest of the test successfully. Assertions, that's how you make assertions. It's just same as test more. You do OK and the values you want to test. Comparisons. This is where Test2 really starts to shine. Instead of having is deeply, it just has is, and it can do both shallow and deep comparisons. So you can see here, you just pop into arrays to is, to hashes to is, and it just knows what to do about it. Is deeply is gone. But it's the comparison is defined by the second argument. So if you give it a string as the second argument, it will stringify the first argument and compare it that way. So it still has most of the benefits that you used to have by having a separate is that was always a string compare. Because if you ask for string compare, that's what you're going to get. Like is now also capable of doing deep checks. You can do the previous like with string and then a regular expression to check against, or you can give it arrays. The difference is like will only check about the things you've asked for. So the second array here just has 1 and 2. So we verify that the first array has 1 and 2 in its first 2 indexes. Then it doesn't care about the rest because it's a less strict check. Same thing down here, and you can pop a regex at any point inside the second structure. It starts at the beginning. The question was if 1 and 2 were at the end of the array instead of the beginning, would this still pass? The answer is no. It does verify that the value is at the correct index. Once again, the right-hand side specifies what type of comparison it is. In this case, we're checking with a string compare. There's a domain-specific language for testing that is, question? Yes, that you can do with the DSL pretty easily. We'll get to that in a bit. Okay, so the domain-specific language allows you to define the structures you want to check in a declarative way. So here we're declaring we want an array. It should have the item X and the item Y. By the way, you can give a specific index on this. You can do item and then the number and then the value, and it'll check that specific index instead of starting at 0 and 1 and so on. And we're saying the last item here is going to be a hash. It should have the field foo with the value bat. It should have the field yikes, or actually specifically in this case we're saying DNE, which is a shortcut for does not exist. So we're checking that yikes does not exist here. And then end, we want to make sure there's no other fields in here, and the end function specifies that. Obviously this test will fail badly because these values do not match these values. And with Test2, you get some really nice diagnostics telling you why it failed. First, it's showing you that it was checking for an array and it got an array. We defined that from lines 3 to 11, as you can see here. A should equal, or we got A, but we were checking for X with a string equality operator. That was at line 4, right here. So what the DSL does is it's able to capture the line numbers, and in cases where you give it a block, the beginning and end line numbers through magic hackery, and it can actually tell you where you declared the check that is failing within the structure. I have updated tests that didn't use Test2 to Test2 simply to find out where and why things were failing. This saves so much time. It's a little verbose, but it is worth it. Questions about the DSL before I move on? It exists. A little bit later, when I get to the comparisons, there's a lot of shortcuts like that, and I'll go over all of them. Actually, I believe when I wrote this, it didn't. This is an older slide. I think I have since updated it so it would tell you that. Okay. ToDo. Many of you have probably used ToDo with test more. It's kind of ugly. You localize a global variable. In Test2, you use the ToDo function. You can do ToDo, reason, and a block, and everything within that block will be ToDo. Or if you want to avoid introducing the additional scope the block brings, you can do myToDo or any variable name you want. This isn't a global variable. You just make it and capture the output of ToDo with a string and don't give it a sub. And as long as that variable exists or is in scope, every assertion you make is ToDo. And as soon as you undefine that or get rid of it, the ToDo state ends. So that's a way to emulate what you used to be able to do with test more of not introducing a scope for your to-dos. So listing dependencies. This is very important. And this is a new slide for this year. If you are depending on things in Test2, you should, or in Test2 Suite specifically, you should depend on all the things you use, all the things you load. You shouldn't just depend on Test2 Suite. And that is because in the future, if we get to like Test2 V4, V5, we might want to move some of the earlier ones out like V0 and V1 into their own distributions for people who are still using them while not burdening the Test2 Suite distribution with them. So you want to specify exactly which ones you depend on so that your tools know how to bring them in. For example, with Distilla, this would be wrong. You don't specify your test requires of Test2 Suite. You would instead specify Test2 V0. And here's the same example in MakeMaker. So, ooh, that slide's broken. I'll move on. So convert was from yesterday's talk. You can go on and look at it if you want. That's instructions on how to convert existing tests to Test2, but I'm not going over that today. So tools. Test2 has the concepts of tools, plugins, requires, and I think that's it, and bundles. Tools are any Test2 packages that are going to export things into your namespace. Things like OK, is, whatever else. There's the basic tools, Test2 tools basic, which gives you OK, pass, fail, diag, note, all the stuff you're familiar with, and test more. Pretty basic stuff. I'm moving on since most of you already know this. Then there's some class tools, such as is OK, can OK, does OK. These are similar to the test more variants, except that they are consistent with each other. In test more is OK, a lot of people didn't know the third argument was actually an alternative name for the first thing you were checking. And most people just actually listed a whole bunch of things they wanted their class to fit the is a requirement of. So now this is consistent. Is OK and can OK, all additional arguments after the first are checks instead of weird alternate naming. You could also give it an array of checks as the second value and provide your own name as the third value. So compare we'll get to later. So defer. Test2 tools defer is something that is really useful if you need to write some tests that would be affected if test more was loaded, or Test2 or TestBuilder or any of them were loaded. It lets you load Test2 tools defer and say def we're going to run this function, give it these arguments, but don't run it yet. Just hold on to these arguments. Then you go ahead and load your tools, and then you run do-def, and it'll call the functions you had specified with the arguments it captured beforehand. That way, if loading the testing tools will change state too much for you to actually do your test, there's now a way to actually test it. This is very good. Excuse me. So this is specifically used when testing Test2 itself, because some of the tests we wanted to run would not be runnable if we were already loading Test2. It's kind of complicated. Once you have a use case for this, you go, oh wait, that's what I need it for. But until you do, it's a bit hard to describe. So moving on, Test2 tools and coding. Okay, so Test2, when you load it, there's a lot of things, a lot of decisions that aren't made yet, such as which output formatter is going to be used, whether IPC is going to be available or not. And these are all decisions that are made when the first assertion is made, so the first time you type OK. But if you want to test that IPC is not available yet, you would maybe write, OK, can I use IPC? But the very fact that you're issuing the OK will cause the decision to be made. And so this lets you write the test without actually sending the event that'll collapse the state. Probably not, but there are a lot of people who do want to test testing tools, and that's the audience here. Yes. Okay, so with TestBuilder, it was fairly difficult to get it to output UTF-8 consistently. There's now a set encoding tool that does all the hard work for you. Pretty easy moving forward. So Test2 tools exception. This is modeled after TestFatal, which Rick here, I believe, invented, except it does a lot less by design. It's just going to capture the exception so that you can use it in a like test or an OK test. This I mainly did because I couldn't depend on test exception for these test tools. Sorry, I couldn't depend on TestFatal for these tools. But I also like that it does less than what TestFatal does. It exports dies and lives, which both take a code block. And then dies will return any exception that is captured, or undef if there was none. Lives will return true or false depending on whether or not there's an exception. If there was an exception, it will warn you about what exception happened, but it will not break the flow. Exports. These have no comparison in Test More. This is a completely new tool. The imported OK, which will verify that the function you list is defined in your namespace, and it will actually check that it is defined in your namespace. It will not check inheritance, because in this case you're checking that a function was imported, not that a method exists. And there's not imported OK if you want to verify things are not in your namespace, or not in your namespace anymore. There are reference-specific tools. Ref OK just checks that something is a ref or a specific type of ref. And there's ref is that verifies that two variables contain the exact same reference by memory address. This is important because with a deep is, you can't just put two references together and have it do what you want. It'll still pass, but it would also pass if you had a deep copy, whereas ref is will only pass if the two refs are the same. And then ref is not. It's pretty obvious. Subtest. There are now two subtest functions available. There's buffered subtests, which have a different output when you're using a tap formatter. It waits until all the subtest is finished running, and then it outputs it as a single block. Unlike the legacy or unbuffered subtests, streaming subtests, which would output the subtest first and then the final result at the end. The reason this is useful is because nowadays a lot of people are writing tests that fork or tests that use threads. And if you use subtests, the classic type of subtests in two different processes or two different threads, the output will get mangled together and you won't actually know which one's which. With the buffered subtest, since it waits until it's done and outputs it all at once, you don't have that weird intermingling of the events. It's kind of necessary for threading and forking. Warnings, this is just a bunch of tools to help you with warnings. Most of them should be familiar. Warns to capture a warning, or true or false that there was a warning. You can also get the list of warnings to do in a deep comparison. You can check that a block of code has no warnings. Just lots of capabilities there. And they're significantly better than the test warn tools that most people use, because it doesn't have to pretend stack frames have disappeared. Won't get deep copy of bizarre array issues that you sometimes get with the other tools. If anyone's seen that message, it's quite infuriating and very hard to figure out what's wrong. Comparisons. So this mostly covers the DSL. This is a, I believe, complete list of things that are exported. You've got your is, your like, isn't, and unlike, which are Boolean false from is and like. Not super useful in many cases, but there are a few cases. You've got match keyword, mismatch keyword, which we'll go over in a minute. Validator to make your own. Hash array bag. Bag would be the answer to your question of whether or not things can be in a different order. And most of these I'll go over. There is no slide for exact ref. That is if you want in your deep comparison to make sure something is an exact reference by memory address. You can do shallow and deep comparisons. Oh, let's go to the state ones. These are the shortcuts that we were talking about earlier. There's true. This will pass for any true value, and you can use this at any depth in your check. So is 1 true? Yes, that'll pass. Is 0 false? That'll pass. Is 0 defined? Yes, that'll pass. And then here we're doing a check for does not exist. We're making sure that the second index in the array does not exist. Here we're checking that the A key does not exist in the hash here. And FDNE is false or does not exist. So really any kind of falsy value, or if it doesn't exist. That's really nice sometimes. Mm-hmm. Correct. Because does not exist is not the same thing as fail, just like undefined is not the same thing as false. So, then directed, even in your is deep comparison, you can still use regular expressions at any point, but you have to prefix them with the match element from the DSL, the match function. So, is foo match OO? Yes, it will. Foo, mismatch AA, that's correct. It's not going to match AA, so that'll pass. Is 12.00 the number 12? Yes, this will pass, whereas if you didn't check a number, it would fail, because 12 is not the same as the string 12.00. So this is how you can enforce I want a number comparison here. It will not automatically try and determine if you want a number comparison. It will default to string, because trying to determine for you whether or not you have a number is insane. So you have to specify where you want the numerical comparisons. You can also check is thing this string. That is mostly pointless because it will, well, it's not mostly pointless. If you had an overloaded object, that would stringify it for you. But you could also just wrap it in double quotes, so pick your poison. Then here we're, oh, I did have this here. And here you're checking that we got the exact ref R as opposed to any empty array. And you can nest these as deep as you want in your data structures. It's really nice. You can make custom ones. I'm not going to go over this because this interface is also likely to change. It's too complicated. You can check sets. You can say, is apple in set pear, apple, orange? Yes, it is. Is apple not in the set dog, cat, cow? Well, it's not in that set, so this will pass. Is apple, or does apple match everything in the set? The regular expression PP and the regular expression A. Yes, it matches both those, so it matches everything in the set. Oh, yes? Yeah. Yes. Yeah. Yeah, to have just, yeah, this, you could put this not in set like 10 levels deep into hashes if you wanted, and it would still work. Whereas if it was its own test function on its own, you'd have to do a whole lot more typing. Arrays, you can say, like I've already gone over, want an array, it should have these items. And in this case, this is an older slide. Here we're specifying end. If there's a change that's in progress, it's already going to warn you about. Is being a stricter check will implicitly add end for you to make sure that your bounds are met, whereas like will not implicitly add end. Recommended practice, though, is to just always put end or the opposite of end, which is etc, at the end of your checks, just to specify this one I want to be bounded or this one I don't want to be bounded. And once again, get really nice diagnostics. I've already shown those and I'm halfway, so I'm going to go ahead and move on. Hashes, same idea. You've got end or etc to specify yes, there can be more keys, or no more keys in this hash. Meta, you can do meta checks. Is thing meta check? Does it have the property where it is blessed to this? Does it have the property where it is this ref type? Does it have the property where it is this size? Which is useful for arrays. And hashes, it'll check the key count. It does not simply stringify the thing and hope for the best. You can also do prop this to recursively check the thing again. Then object, if you're checking an object, so we've got an object, the object block can take anything that meta can take, and then it can also take either field or item, depending on whether it's a blessed hash or a blessed array. And then you can also call methods on it and verify the result. And the method can also be a code ref if you, say, want to wrap something in array brackets, because it's going to return multiple values. Okay, any questions about comparisons before I move on? Okay, plugins. Plugins are different from tools in that they have usually global effects on Test2 as a whole, but they do not export anything to your namespace, because that is the distinguishing thing between plugins and tools. This one, bail on fail, is something that people have wanted for at least 10 years, but no good implementation or perfect implementation has existed. TestMost has something similar, but it didn't quite reach the end goal. So this feature, it'll make it so that your test will bail out on the first failure, so you don't keep running the test after something has failed. The TestMost implementation would wait until the next assertion before bailing to ensure that all the diagnostics were output, because with Test Builder, if you just failed immediately when the OK failed, your diagnostics of why it failed would not be output. But with that implementation where it waits till the next assertion, you might have a really long-running thing before the next assertion, if there's a next assertion at all, so it doesn't bail as soon as you would like in some cases. With Test2, I've solved the fundamental problem that prevented the diagnostics from being output. So with bail on fail, you will bail immediately after the failed OK, but you will still get all your diagnostics. Die on fail is the same thing, except instead of a bailout, you have a die, which means other tests will still run. Is essentially the difference there. Exit summary. This is a bunch of diagnostics at the end of the test to say, like, hey, you didn't follow the plan, things of that nature, or you failed X tests. This one is one that I really like to load in my tests. What this does is it will seed random with the current date. That means every time you run the test on a given day, the random behavior will be reproducible. So it's just consistent. However, you can seed the random with a specific date. So say you notice there was a failure on one day that doesn't occur on any other days. You can now reproduce that, and you can reproduce the Heisenbug. This really helps you to track down bugs due to random behavior. And since it is seeded with the current date, as your test runs from day to day to day, if you have integrated testing or whatever, if there is a Heisenbug due to random behavior, you will eventually still see it. It won't be hidden forever. I did not come up with this idea, but this is the second time I've implemented it, but this is the main implementation of such behavior on CPAN, and it is really helpful. There's also the UTF-8 plugin that will just UTF-8 all the things. It sets all the outputs from Test2 to UTF-8. It sets your standard error and standard out to UTF-8. Everything's just UTF-8 for the testing. There's some debate among other authors who are working on Test2 of whether or not it should set standard error and standard out. So just stay posted because we have not solved that debate yet. Requires. These are a type of module that will cause your test to skip if certain conditions are not met so that you don't have to hand code these, such as author testing. Use this and your test will only run if the author testing environment variable is set. You don't have to manually do that in a begin block anymore. Envar is the more generic form of, hey, only run this test if this environment variable is set. Test require fork. This will cause the test to skip if the system you're on doesn't have any kind of forking support whatsoever. And you think, oh, well, that's easy enough to implement yourself. No, it's not. It is not easy to implement yourself. This is the full, complete one that probably still has a few bugs. Real fork. This one is only if your system really and truly supports forking. So this will be false on most Windows implementations, even though they do have the fork keyword. Module. This will only let your test run if this module is installed, optionally with a version. Of course, there's plenty of implementations of such a thing on CPAN. This is one of two that actually directly use Test2, so that you don't need to load TestBuilder to get the behavior. It can also require a certain version of Perl. This will skip the test instead of saying, hey, instead of dying, saying that your Perl version isn't sufficient. And then threads, same as fork, except for threads. And once again, it's not an easy check to do yourself. Lots of complicated stuff in there. Questions about require modules? Okay, mocking. Test2 Suite comes with a mocking library. It is like the new version of mock quick for anyone who used that. Basically, with the mocking in Test2, you always get a control object. Control object is how you make mocking happen and how you control when the mocking goes away. So it's scoped. If your control object goes out of scope or gets destroyed, all the mocking goes away as well. So you don't have to worry about your mocking leaking from one block to another. So here's an example usage. Create the control object. Now, there's shortcuts, so you don't actually have to manually do this. This is just an example. We're going to take the class myClass. We're going to override the sub called name, and we're going to add a method is mocked. Then here we're going to, still with the control object, override name again. And then we're going to restore our previous mock, so this will go back to being Fred. Then we're going to reset the mock completely, which will just get rid of all our overrides to name. So it's basically a stack, but you can also remove them all at once. Then when you undef your control object, all your mocking just goes away. Everything's restored to where it was before you started mucking with it. The tools to help you actually do this, so you don't have to write the big control object constructors, are mock, mocked, mock class, and mock object. Mock is sort of a universal, it can do all of them. Then mock class and mock object are more explicit forms if you don't think it's very clear when you just use mock. I don't have examples of those right here, but I recommend you look at the documentation for details there. But here's an example. We're going to mock some package. We're going to add foo sub, and we're going to override the bar sub. Now we're calling some package foo, some package bar, and boom, we're getting rid of the mock. So you can tell to mock a class just by giving it the class as the second argument. To mock objects, you would do mock and then a reference that should be blessed into the object. So in this case, bar is 1. We're going to add the foo subroutine, and we're calling foo, which is what we added. And then you're looking here, we're calling bar, but we didn't specify a bar subroutine. We just specified a bar value. With the object mocking here, any method you call will be auto-vivified as a read-write accessor. There is a strict form of this if you don't want that behavior, but this is very useful if you just want to throw something in an object and say, just try to work really hard, and it'll just auto-vivify the methods for you. And this creates an anonymous class when you do it this way. It's blessed as just some random garbage string class. Questions on the mocking? Spec. This is my favorite thing about Test2. This is developed largely from a previous framework I wrote, Fennec. It is very heavily borrowing from RSpec in Ruby, for anyone who's familiar. Who in here is familiar with RSpec from Ruby? A couple of people. Okay. So first of all, you've got test blocks. These are essentially subtests, but they don't run immediately. So we're creating a bunch of subtests. You can give them parameters though, such as ToDo. This test is ToDo. Everything in it is ToDo. Now you don't need to call the ToDo keyword and manage your to-do state. Or test very bad, skip, because this will RMRF slash. So it won't even run the block. It'll just say, hey, we skipped this block. Then at the end, you put done testing. And done testing is what kicks off these test blocks. These test blocks don't run when they're defined. They run at the very end when done testing is seen. So you have to use done testing with this framework. There's lots of different params you can give these things. You can do flat, which means it won't render as a subtest. All your assertions will be in line with the scope they were defined in. To do and skip I went over. ISO. This means isolate. If you're on a system that supports true real forking, it'll fork before running that subtest and manage cleaning that for you as well. Async means you can fork or parallelize this, but you don't have to. So on a system with real fork, it might fork to run it. If you don't have fork, but you say you're on Windows and you have threads, then threads will be used for the async or isolation. That way, any change you make to global variables or whatever in that subtest will not affect any of the other subtests because it's been isolated. Really, really useful, let me say. Describe. This lets you group test blocks together. So you've got describe color, test for red, green, and blue. Describe size, test for small, medium, and large. And then we're nesting another described under it. This is useful to group behaviors, which I'm going to go over next. You can do a before all, after, or before all and before each. Before all will run before all your test blocks. It'll run exactly once. Before each will run before each of your test blocks again and again and again. So before all is set up an initial global state. Before each can be a reset state before you run this test block type thing. And then you can also put those inside the describe. This before all and this before each will only affect these tests, whereas this before all and before each will affect all those tests and this test that's outside of that described scope. And this is largely why these don't run until done testing is hit, because if they were run the moment they were seen, behaviors might get missed. So it actually has to compile things from what you've declared. There's also after all and after each. There is around all and around each, like if you wanted to localize a variable or something and then run the blocks. There are cases. This is where it can get dangerous though, because you can put too many cases in too many tests and nest them and then just have an ungodly number of subtests eventually run. But we've got the case red, where we set our variable C, which is scoped to this describe block, to red. We've set the variable green and blue, so different cases for a variable C. This could also be for object states. Test validator, is valid color? And visible, is visible? Yes, all these colors are visible to most people, and yes, they are valid colors. But it'll run validator for all three cases, and then it'll run visible for all three cases, which in this case means we are running 6 subtests. And here's the output, which I think I screwed up because it's not showing the visible. But anyway, case mods. Yes, you can even modify your cases. You have before case and after case and around case. And by the way, here's the documented order of execution for all these. You've got your before all, then for each case, you've got the before case, the after case, and then for each of the test blocks, you've got the before each, then the test, then the after test, and then at the very end, you've got the after all. So yes, the order is known, it is documented, and you can rely on it. Mocking. As I'd mentioned, the mocking in Test2 uses a control object. If you are using the spec framework here, the mocking behaves as a before each. So you can just put your mock in your describe and it'll affect all the test blocks in there. You don't have to worry about capturing control yourself. Really handy. You could also put the mock inside the before each or inside the test and it'll capture the control for you. Or if you don't want it to, you simply actually capture the control and it'll go, oh, it's captured the control, I'm not going to touch it. Very, very handy. There's a DevilDeclare syntax plugin for all this, which I will vouch for. I've used it at 2 workplaces now, not having any issues. It lets you do describe, foo, kind of like a function here with your arguments in here, and then the block, and you don't need the trailing semicolon. So you get rid of trailing semicolon, get rid of the sub keyword. The parameters are more like a function signature. And yeah, it uses DevilDeclare because that's the most consistent, works all the way back to 5.8. So this makes writing these kinds of tests really, really nice. No, DevilDeclare. Yes. So the question was, does it use a source filter? No, it uses DevilDeclare. Bundles. Bundles are groups of plugins, tools, and any other things. Anyone can write any kind of bundle they want, but this is where, like, say you like some of the tools that Test2 provides, but you don't want all of them. You like some of the plugins, but you don't want all of them. Make your own bundle. The one I recommended you use, Test2 v0, is simply a bundle, and it loads pretty much all the things. There's also the Test2 bundle more, which is almost a drop-in replacement for Test more, not quite. There's one for Test simple too, largely because it was really easy. But writing bundles is really simple. You can look at the examples that are already there. That is where you will group plugins and tools together. I've recently started ZipRecruiter, who, by the way, gave me the time off to be here. Thank you, ZipRecruiter. And I came in and they've already got their own custom bundle as well. They're really easy to write and they're really useful. Context. How much time do I have? 10 minutes? Okay. So context is the interface for test writers. So if you're interested, or sorry, test tool writers. So if you're interested in writing your own test tools, context is important to you. It is the primary interface for Test2. It is also how we solved the bail on fail diagnostics problem. Basically, the usage is whenever you enter into a test function, so we're making myOK, you, as soon as possible, want to acquire the context object. The context object is then how you issue events such as OK, diag, or any other events you want to output. And then when you're done, you call ctx release and return whatever you want. A lot of people are saying, well, why don't you just let it automatically garbage collect? The answer is because there are behaviors attached to this, such as bail on fail or die on fail. What a lot of people don't realize is that if you die in a destructor, it's just eaten. Your code doesn't actually exit. You don't actually die. It just kind of happens. That is why implementing die on fail was so difficult with TestBuilder, or one of the reasons. With this release, we can say, okay, release, which means we're not going to output any more diagnostics, so die now, and since we're not in a destructor, we'll actually die. So that is how you actually get all your diagnostics and actually die. Before having this context, it was pretty much impossible to do this because the test builder singleton never actually goes away until the end of everything. And if you just failed when you called OK, your diagnostics, which is going to be later code, wouldn't be output. But now the behavior is on release, we die. On release after a failed test. Rules for context. Get it as early as possible, release it as late as possible. Do not forget to release it. Each sub should get its own. You do not want to pass these around. Do not cache or store the context to use later. Do not share the context and assume it is obtained, or it assumes it is obtained within a sub, not a package scope. And do not alter the context internals, and do not monkey patch the context. Because if you do any of these things, shit will break. Now, I've worked really hard to make it give you really nice errors if you do some of the easy ones. Like if you forget to release a context, it'll notice the next time you try and obtain a context that there's already context, but it looks like it was created in a totally different place. And it'll give you a really nice output saying, hey, something did something wrong, the contexts don't match, here's the things to look at to try and fix it. It's like this long on my screen of, here's how to help you solve this problem. I've done a lot of things in Test2 to try and solve these because I've made the mistakes too. I have dog-fooded all of this. Test2 tests itself. So whenever there was a pain point, I'm like, no, we're going to fix that. And then events are generated via the context object. Call OK, note, diag, there's a whole bunch in there. Or if you want your own custom events, there's send event or build event if you want to create it but not send it. Questions about context? Yes. Yes, the context, yes, so the question is, can you get the line number and other data from this? Yes, the context is where that data is stored. That is where the line number, if a failure happens, or that is where it gets the line number to report to you when there's a failure. It just has a lot of context, oddly enough, about the current running test. I know I'm really short on time, so I'm going to jump here. There are some things that are coming soon. The current event system is limited. I'm updating it with something called facets. It should come out sometime this year. It really makes the event system a lot richer and a lot more powerful. Optimal pass. I'm adding a pass event that bypasses a lot of the internals of Test2 because it's a pass. You know, no state is really going to need to be modified. Performance. Here's the numbers you saw on that first tab at the very beginning. With facets and optimal pass, we have yet again made it significantly faster. I'm not going to go over all the numbers due to time constraints. New compare. The current comparison tools are implemented in a way that is pretty complicated. If you want to write your own comparison, it's kind of painful right now. So I'm working on an alternative. The overall interface you use won't change, so it's not like you're going to have to learn a new DSL, but the internals of how they work is going to change. That is something that is going to be released under a new version bundle, such as V1 or V2, so you won't have to modify any existing tests either. You don't have to worry about that. Then YATH, yet another test harness, also known as Test2 harness. It is an alternate to prove that has load or preload and fork as an option, not by default, but it's there, as well as it will be able to support any Test2 formatter that you write. So if you don't want it to output TAP, it won't. It's just a much cleaner test harness. There is a version out on CPAN that's a prototype, and it works for the most part. I know a few places that are, unfortunately, using it in production. But all the internals are undergoing a complete and total rewrite to make a few things better. So keep an eye out for that. And that is it for my slides, and now it is all questions. Yes?
What part of this already ships with the Perl 5 distribution?
Very little. So the core Perl 5 distribution has Test Simple, which includes all the internals of Test2, but none of the tools of Test2. These tools were deemed too complicated to immediately dump into core. They need to be a bit more mature if they're ever even going to make it into core. Just because there's so much here, it's just not something that I could have just bundled. Initially, it was bundled with, but P5P and Rick and a few others asked me to split them out. So to use the things I've talked about, you have to install Test2 Suite. Although, like I recommended at the beginning, you should actually ask for what you want. Test2 V0, Test2 V1, or if you just want some other tools, Test2 tools compare, whatever else. That's what you should depend on and try to install the CPAN. Other questions? That is a typo. Second one should be die on fail. Okay. Yes. That's what they do. So the question is there a way to make the requires, such as requires module, to skip the test? That is what the require modules do. That is their purpose. Yes, if you do a subtest, well, no, because it's in a begin block. No, you cannot use these for that purpose. Yes. Or manually do it. Yes. The question was, if this test fails, don't run the following 5 tests. Yes, the simple answer is do if, okay, and then put the other test in a block. Other questions? No? Okay, well, I'll be around the conference through today and tomorrow, so if anyone has any other questions or just wants to talk about testing, please come up to me. I do not mind.